In this video, we'll talk about the graphs of absolute value functions. So let's just go ahead and start with an example. Let's say we just wanted to graph the absolute value of x. So recall that absolute value is distance from 0. And so essentially if we're looking at a t-chart, if I plug in 1, well, that's 1 away from 0. If I plug in 0, that's 1 away from 0. If it's 2, it's 2 away from 0. And if I do some negatives, negative 1 is 1 away, and negative 2 is 1 away from 0. So basically, this absolute value function, if it's positive, it's fine. If it's negative, it changes the sign. So if we look at what this looks like on a graph, well, we go through the origin, 0, 0. We also go through 1, 1. We also go through negative 1, 1. And likewise, 2, 2, and negative 2, 2. And what happens is it actually forms this very sharp V shape. And the whole idea of what we're doing when these things get more complicated is that we're trying to find this point, which I call a V point. You could also call it a vertex. There's a lot of names for this thing, but I call it a V point to kind of draw emphasis that, hey, these things, they look like V's. They're very sharp, very much bent at a very unnatural angle in terms of normally when we graph a function, it's either a line or it has some curvature to it. But the idea is we are trying to figure out ways to find this V point. And the idea is that happens when whatever is inside the absolute value is equal to 0. And that'll come in handy in our next example. So let's say I wanted to graph this function, y equals the absolute value of 2x plus 1. This one's a little bit more difficult in that if I'm trying to graph it, do I know exactly where that V point is going to land? And that seems like that's a point that I need. Now, if I can find that V point, I only need 3 points to graph this thing. So I'm going to show it, or I'm going to demonstrate a trick here to kind of help iterate this point. So the idea is I know this thing is going to turn when this is equal to 0. So I'm going to go ahead and just set it equal to 0. So whatever's inside the absolute value, we're going to set that equal to 0, and we're going to solve for x. So this would mean 2x is going to equal negative 1, and x is going to equal negative 1 half. This is the x-coordinate for my V point. So the idea is, now we're going to make a t-chart. And okay, the first thing I'm going to do is I'm going to plug in negative 1 half. Now what's going to happen here, since there is no like plus 7 or whatever out here, it's just going to be 0. That's where my V point is going to be. And if I plug it in, I get negative 2, or 2 times negative 1 half, which is negative 1 plus 1 makes 0. Therefore, the y-coordinate is 0. That's my V point. And I'm going to go ahead and plot that point. So add 0, or negative 1 half and 0. So let's say there's 1. That's my V point. I know that it's going to bend at that point. So now what happens if I kind of think about this in terms of a vertical line? I need a point to the left of this, and I need a point to the right of this. And it doesn't really matter so much, so I would just pick whatever is convenient and easy to work with. So if I pick something to the right, let's say I pick 1. 1 is greater than a half. That'll work. So I'm going to plug in for x. 2 times 1 is 2, plus 1 is 3. The absolute value of 3 is, well, 3. Cool. So I know I go through the point 1, 3. And that would be the right half of my V. Now I have to do the left half, so I have to pick a number less than the negative 1 half. I'm thinking the next easiest point to work with would be a negative 1. So I'm going to plug that in for x. Negative 1 times 2 is negative 2, plus 1 is negative 1. The absolute value of negative 1 is 1. So I know it goes to the point negative 1, positive 1. And at this point, I can finish off the other chunk of the V. So I did it with 3 points. And the reason that we did this math over here was so that we could precisely figure out where to put that dot. The V-point is very important. It's very important to know where these things turn. It's probably the most important point on this graph. It's the key feature. So there's two examples, one that's a little more complicated than the second. The same concepts apply, though. If you're looking for the V-point, whatever you have in absolute value, set that equal to 0, solve for x. That will give you the x-coordinate of your V-point. After that, you just got to pick one to the left and pick one to the right. That way you know where to draw the other two, or the two parts of the V, I suppose. So that would be enough to get you started. Good luck.